Welcome to today's deep dive. We're going to be looking into a very unique energy concept.
Okay.
Basically, we're talking about using the incredible pressure that's at the bottom of the ocean to make clean energy.
Ah.
No fossil fuels, no solar panels, just pure water weight, creating heat and steam, and then using that to power turbines.
I like it.
So imagine a giant natural pressure cooker just sitting on the ocean floor, silently making enough power to run cities.
Entire nations, maybe?
Yeah, exactly. Even entire nations.
It's a pretty cool idea. It really uses a basic physics principle,
Hmm.
how pressure and the boiling point of water are related.
Right. We all know that water boils at 100 degrees Celsius at sea level.
Right.
But what happens when you really increase the pressure? Like way up as you'd find at the bottom of the ocean.
The boiling point changes. It goes up.
Okay.
So the deeper you go into the ocean, the more pressure there is, and the higher the temperature that the water boils at.
So how do we use this to make electricity then?
So picture this. At about 1,000 meters deep, so that's over 3,000 feet, the pressure is so strong that water can get hotter than 265 degrees Celsius without actually boiling.
Wow.
That's hot enough to make some really powerful steam.
So no need for external heating.
Nope. No burning fossil fuels, no complex solar panels, just completely natural pressure.
No.
It's like the ocean is a giant energy source we haven't even touched.
Okay, so let's talk about how this actually works. So we've got this superheated water way down there. What's next?
That's where the pressure cooker idea comes in. We can basically build a closed system that copies those conditions at the bottom of the ocean. This system would have water that's allowed to heat up under all that pressure. As the water gets to its new higher boiling point, it turns into steam. And we use that steam to power turbines that are connected to generators.
So we're basically making a controlled environment that taps into the ocean's natural pressure cooker effect to make a steady stream of steam.
Exactly. And that steady stream of steam means we get a reliable supply of clean energy.
Okay, I'm seeing how this could really work. But can we actually scale this up to power something big like a city?
So let's look at some numbers. Calculations show that one pressure cooker unit working for a bit less than 5 hours a day could probably generate enough power for a town of about 1,000 people.
Less than 5 hours to power a whole town. That's incredible.
It's definitely an interesting possibility. Of course, powering bigger areas would need multiple units and a strong system to get that energy out and spread it around, but the basic idea is the same.
So we could have these underwater power plants just running 24/7, giving us clean energy without using fossil fuels and not hurting the environment the way that normal power plants do.
In theory, yeah. The really exciting part of this idea is that we could make a lot of clean energy, especially when you think about how huge the ocean is and how deep these high-pressure zones go.
What would it take to make this happen on a global scale then?
Well, imagine 10,000 of these units carefully placed all over the ocean floor. And remember, the ocean covers over 70% of the Earth's surface. We could theoretically make enough power to run millions of homes.
That's game-changing. But I bet the cost of building and installing all those units would be crazy high.
You're right. The initial investment would be a lot. Early estimates say that a project this big could cost something like $3.5 trillion.
Wow, that's a lot of money.
It is. But we need to look at the long-term advantages and potential profits. The projected yearly revenue, if you think about using less fossil fuels and selling clean energy, could be in the tens of millions.
So even with that huge initial cost, this technology could eventually make money and become a sustainable alternative to the energy sources we use now.
That's the hope. The idea is ambitious for sure, but the potential benefits, clean energy and less reliance on fossil fuels, make it worth exploring.
Okay, so we've got the basics, we understand the science, the scale, and what it might cost. But what about the logistics of building and maintaining these massive structures underwater? I mean, we're talking about depths of over 3,000 feet.
Yeah, you're right. Building anything at that depth is a huge challenge, and we'll look at all those details and the technology hurdles next time.
That's good.
Welcome back to our deep dive on underwater pressure cooker energy.
So last time we were talking about the massive engineering challenge of actually building these things.
And that's what we're going to get into now. We're talking about crazy depths, extreme pressures, and a corrosive saltwater environment. It's not easy.
No kidding. So how do you even start designing something that can handle those conditions for, like, decades?
So you got to start with picking the right materials. We need materials that are super strong, long-lasting, and resistant to corrosion.
What kind of materials are we even talking about? Is there anything out there that can take that much punishment?
There are some good options out there. Titanium alloys, for example, are known for being incredibly strong light and corrosion resistant.
Okay.
They already use them in things like aerospace and medical implants, so they can definitely handle a beating.
Yeah. Titanium sounds like a good fit,
Mm.
but I'm guessing it's pretty expensive.
True cost is a big factor. Titanium is not cheap, so researchers are looking for ways to use it more efficiently, maybe combining it with other materials or using it just in specific spots of the structure.
So finding that sweet spot between strength, durability, and keeping costs down.
Yeah, exactly. Another option is high-strength steel, specially made for deep-sea use. These steels are designed to handle extreme pressure and resist corrosion.
But steel's heavy, right? Wouldn't that make it even harder to build and transport these things?
That's a good point. The weight of steel would definitely make things more complicated. That's why some researchers are looking into using advanced composite materials.
Composites, like what they use in airplanes and racing bikes.
Exactly. Composites are basically combinations of different materials, each one with its own special properties. By carefully picking and layering these materials, engineers can make structures that are super strong, light, and corrosion resistant.
So it's kind of like building a super strong Lego structure where each brick helps make the whole thing strong and functional.
Yeah, that's a great way to put it. The cool thing about composites is that you can customize them a lot. Engineers can fine-tune those material properties to fit the specific needs of the deep-sea environment.
This is all sounding really promising. But I imagine working with composites at that depth and scale has its own challenges.
Oh, definitely. Manufacturing and putting together composite structures underwater would be a huge task. You'd need specialized equipment and robots, maybe even invent totally new underwater construction techniques.
So we're talking about pushing the boundaries of material science and deep-sea engineering.
Exactly. This project really makes us rethink what we can do underwater.
Okay, so we've talked about the pressure cooker itself. But what about all the other parts, like the turbines, the generators, all the wiring?
Yeah.
That stuff's exposed to those harsh conditions too, right?
Oh, for sure. Traditional electrical stuff wouldn't last down there. We need special underwater versions using materials that can handle the pressure and won't corrode.
So a whole new kind of underwater electronics.
Exactly. And it's not just about what they're made of, it's about the design. They got to be compact, efficient, and able to work reliably in that extreme environment.
Are there any examples of this kind of tech being used in other deep-sea stuff that we can learn from?
Actually, yeah. The oil and gas industries has been working in deep-sea environments for years.
Right.
They've developed specialized equipment and technology that can handle those conditions.
So we could maybe adapt some of that existing tech and use it for this new energy system.
Exactly. We don't always have to start from scratch. Working with experts from other fields like offshore engineering could really speed things up.
That makes sense. So we're making progress on the materials and component side of things. But how do we actually get the energy from those underwater pressure cookers up to the surface and onto the grid? That seems like another big hurdle.
That's where energy transmission comes in. And yeah, it's a key part of the whole puzzle. We're talking about sending a ton of electricity over long distances and doing it efficiently and safely.
I can just imagine those big cables carrying all that electricity being pretty tempting for marine life, especially those curious critters that like to nibble on anything new.
Yeah, that's a real concern. That's why engineers are designing super tough cables. They're looking at things like special coatings or even burying the cables under the seabed to protect them.
And then there's the whole issue of energy loss during transmission. The farther it has to travel, the more energy you lose, right?
That's true. It's definitely something to consider. One solution is to use high-voltage direct current HVDC transmission lines. They're more efficient for long distances than the usual alternating current AC lines.
So picking the right kind of power line and making sure it's protected is key to minimizing energy loss and avoiding any unwanted run-ins with sea creatures.
Exactly. It's all about finding that balance between efficiency, reliability, and being environmentally responsible.
This whole concept is starting to feel like a giant jigsaw puzzle, with each piece, the materials, the design, the transmission infrastructure, all playing a crucial role.
It is a complex puzzle, but it's one that scientists and engineers are working hard to solve. The potential benefits of clean energy are just too big to ignore.
Well, we've explored the material challenges, the components we need, and even touched on the complexities of energy transmission. What other hurdles are left before this pressure cooker energy dream becomes a reality?
One last but very important piece remains: maintenance. How do we make sure these systems run smoothly and reliably over the long term? We'll dive into that next time.
Welcome back for the last part of our deep dive into underwater pressure cooker energy.
We've talked about the science, the potential, the amazing engineering, but now we have to talk about the big question: maintenance.
Right. It's one thing to build these incredible underwater power plants, but how do you keep them running smoothly in such a crazy environment?
That's a question that keeps even the best engineers awake at night. We're talking about systems working thousands of feet underwater under intense pressure and constantly dealing with corrosive seawater.
Yeah, it's not like you could just send a repair team down there with a toolbox every time something breaks.
Exactly. Traditional maintenance just won't work. We need to think differently. Design systems that are not just strong, but can take care of themselves.
So how do you build a self-maintaining underwater power plant?
Redundancy, that's the key. Think about having multiple turbines and generators in each unit.
Okay.
So if one fails, the others keep going and everything keeps working.
Like having backup systems for your backup systems.
Exactly. And it's not just the main parts. We're talking backup sensors, control systems, even multiple ways to transmit power.
Oh, wow.
There's always another way if one gets blocked or damaged.
So you build in layers of redundancy to make sure the system can keep running even if something goes wrong.
Exactly. But redundancy alone isn't enough. We need to keep human involvement as low as possible. That means creating systems that can monitor their own health, figure out problems, and even do basic repairs on their own.
Wait, are we talking about underwater robots acting like little mechanics, fixing leaks and replacing parts?
That's one exciting possibility. Researchers are looking into using remotely operated vehicles, ROVs, and even autonomous underwater robots to do regular checks, find potential issues, and even make simple repairs.
That sounds like something straight out of a sci-fi movie. Tiny robot crews keeping everything in perfect shape.
It's a really cool field, and advances in robotics and AI are making these ideas more and more real.
It sounds like we're entering a new era of underwater engineering where machines and humans work together to keep these complex systems running.
It's a promising future, but even with all these advancements, we'll still need human experts.
So how do we get humans down there safely and efficiently when we need to do major repairs?
That's another area where innovation is crucial. One idea is to have special underwater habitats or docking stations where human technicians can live and work for long periods.
Like underwater cities for engineers.
Kind of, yeah. These habitats would give humans a safe, controlled environment to do complex repairs or upgrades without having to constantly go back and forth to the surface.
That's incredible. So it's not just about building power plants. It's about creating a whole new way of life under the ocean.
It's a total shift in how we think about things. And it's not just about engineering. Scientists from all kinds of fields are doing amazing research to figure out how to make this technology work and make it sustainable.
What kind of research are we talking about?
Well, marine biologists are studying deep-sea ecosystems to see how these structures might affect marine life and how to minimize any negative impacts. Material scientists are always trying to make new alloys and composites that are even stronger, lighter, and more resistant to corrosion.
So it's a whole team of scientists working together to make this dream a reality.
Exactly. It's not just about solving the problems we have now. It's about thinking ahead and making sure this technology will work for a long time.
This deep dive has been amazing. From that first spark of an idea to the details of engineering and scientific research.
Yeah.
Harnessing the power of underwater pressure cookers is a huge task, but it's something we can do.
Yeah. It shows how inventive humans can be, our constant curiosity and our drive to find new solutions to global challenges.
And it reminds us that the most groundbreaking discoveries often come from the most unexpected places. Who would have thought that the answer to clean energy might be thousands of feet underwater in the crushing pressure of the deep ocean?
As we keep exploring our planet both physically and intellectually, who knows what other incredible things and solutions we'll find.
Wrapping up this deep dive, I'm in awe of how huge this idea is, and I feel hopeful about a sustainable future.
Me too.
We've got a lot of work ahead, but the potential rewards are too big to ignore.
It's a challenge we should take on a journey worth going on. And maybe someday these underwater pressure cookers will be a normal part of our world, powering our cities, fueling our industries, and lighting the way to a brighter future.
A future where the ocean, this incredible source of wonder and inspiration for centuries, becomes a source of clean, unlimited energy. Thanks for joining us on this deep dive. Until next time, keep exploring, keep asking questions, and keep pushing the limits of what's possible.